Hi, and welcome to the third part of the third tutorial in the SIDD online tutorial series. In this tutorial, we'll be looking at how to go about using the model to generate the effects of a policy counterfactual. This builds on the preceding two parts, which defined the subject for analysis and discussed how the model code needed to be altered in order to undertake the analysis that we're interested in here. Now recall from the preceding sections to this tutorial that the analysis that we're conducting is really framed around 6 alternative specifications, focusing on 2 alternative policy counterfactuals and the sensitivity of the effects of those counterfactuals with respect to 3 alternative behavioral assumptions. As noted in the first tutorial, we'll only really be focusing here on one of these 6 alternatives, but by working through one alternative, hopefully you should be able to work out how to do the remaining 5 in your own time. So what is it that we'll actually be doing? Well, we'll be projecting the effects of the policy counterfactuals using the SIDD microsimulation model, and that really involves 3 key steps that are really well understood within the related literature. The first step involves generating a base policy context. This is the context that assumes sort of policy as usual, unchanged policy through time. The second step involves generating the policy counterfactual. Basically, you hold all of the features of the simulation the same as under the base policy context, except for the change in the policy that you are interested in. So this is really a controlled experiment in the sense that we're effectively considering what an identical population would look like if, instead of associated with the base policy context, it was associated with this counterfactual policy context. Now, what that means is that the effects of the policy counterfactual can be obtained in step 3 of this analysis by simply subtracting moments estimated moments, for example, means of variances and so on, evaluated under the base policy context from the same moments estimated under the counterfactual policy context. And that gives you a measure of the effect. Now, as noted in one of the preceding slides, this model really isn't a forecasting tool. And that is fundamentally because the model itself doesn't incorporate a lot of the uncertainty that really affects forward projection. So it is a nice tool for trying to infer likely effects going forward. And certainly for trying to identify the incentives embodied in policy counterfactuals. In this analysis, we will sidestep all of the issues associated with evaluating prediction errors, primarily because the model really isn't set up to do that properly. As noted in a previous slide, to do that properly isn't actually a huge step from what we have in hand at present, but it would require some variation, and that's something that we hope to get to in the next few years. So that's where we are. So let's get into the specifics of enabling this 3-step modeling approach right now. Okay, so I've saved all of the materials that are needed in order to conduct the analysis associated with this tutorial into the temp directory of this workstation. You can see that there are 2 subdirectories here. One of them is referred to as materials. I have extracted the zip folder that you can download from the web page of this tutorial that's referred to on the web page as materials into this subdirectory. I won't be discussing all of these files in detail here. You can look at a description of what each of the files that's contained in the zip file are by reading this contents file that's included with the zip directory. I'll skip over that for the moment and jump straight to the model subdirectory. Basically, this model subdirectory was created using this installer file, and that loads in these subdirectories here. I've also already generated used this stator code in order to generate the extract the data from the wealth and asset survey, from which model projections using SIDD begin. So that's this starting pop file here. So we're all ready to go. In order to fully replicate the analysis that is reported in the paper associated with this tutorial, you would need to begin by first of all obtaining the full set of source codes for the model. At the moment, these source codes aren't provided by default with the installer. You would need to go through a secondary application process. Basically, it just involves sending an email requesting access to the source code for the model. We'll then email out the source code for you, and then you would load the source code into this subdirectory. And one of the subfolders within this Fortran directory would then be called SIDD, and you would simply copy the files that are reported in the edited source of the materials, in the zip folder of the materials to this tutorial, and you would replace the associated files in the SIDD folder of the Fortran source files to the model. Recompile the model. That basically regenerates a whole new set of model source files, and then you're ready to go. The only additional step that would be needed, that is needed in order to proceed really, is to replace the job file that's in the model subdirectory by default with the job file that is included as part of the model materials, so the tutorial materials. So I'll copy and I'll paste that into the model subdirectory. Now, if we open that job file up, you'll note that first off, the job file includes the amended cells that we altered in order to include a switch to turn on and off this new functionality that we included in the model in order to simulate the case in which labour supply responses are assumed to respond optimally to a policy counterfactual, but consumption and pension participation decisions remain functionally invariant to a policy counterfactual. Aside from that, there were a couple of other additional changes to the default model parameters in order that were made before the model was launched for the current analysis. To see which parameters they were, you can look at this check sheet. Notice that in cell A1 there are 3 changes relative to the model base. Note that that cell Y17, which is the switch, isn't one of them. We're turning that switch off by default because we want the base simulation that we're trying to generate in the first instance with the model to describe behavior that responds optimally to the base policy environment. So that isn't a change relative to the simulated base parameters. If you scroll across horizontally, you'll see that BU3 has 3 differences. So all 3 differences are there, and you can see that the differences are on rows 11, 13 and 15 of column BU. If we look at the input sheet and we see what they are, BU11 is 2030, 13 is 11 rather than 6, and 2030 in row 15. So basically all of these changes relative to the base are designed to ensure that young birth cohorts are affected, or young birth cohorts who are projected through by the model are affected by the policy reform that is the subject of analysis here. So otherwise you actually don't need to change anything in this job file. We can close it up. And to begin, we just double click on the SIDD executable file, and that will begin running through. So basically this simulation, all it's doing, as we noted just a little while ago in this tutorial, is it's projecting forward the cross-section from 2011, which is loaded in from base data described from the Wealth and Asset Survey, and it's projecting that cross-section forward to 2016 based on the 2011 policy environment. And it does that because the 2011 policy environment was the environment that you assumed for the model calibration. Okay, so this simulation will take around about 5.5 hours to run on this workstation. So we'll come back once the simulation is complete. Okay, so the simulation ran all the way through. It provided a message saying that the requested simulations were completed. I closed the executable window, and now we're ready to get into the second simulation. So to do that, we open up the job file and we press Alt F8 and we run the macro SIDD run. Now if you encountered a problem on your own computer running through those steps, it's likely that your version of Excel has macros suppressed. You'll need to allow macros to run before you can proceed using the model structure that we're looking at here. So basically now what we want to do is we want to create a base with the simulation we've just run. Now by default this macro reports the simulation we've just run as the name of this name to adopt for existing job file. So we'll just copy that name and we'll paste it into the name of run to adopt as new base. We'll paste that in there. You can put in whatever name you'd like for the directory of this new base. I like to keep the names the same so that I can track them down later if needs be. And then you just press this convert run to new base button. And what this button does is it basically copies and pastes all of the files that the model needs in order to project a population through time. And it does that by copying the results for this simulation that we've referred to in this box here. You can see it's just finished, so we hit OK. And what you should be able to see now is that in this base file subdirectory is this 2011p _ base folder. And basically what that macro has done is it's copied all of the simulated data that are necessary in order to project the model through time into this folder here. So now what we want to do is project the model forward from 2016 through to 2050 on the basis of the 2016 policy environment. So we double click on the job file, we hit Alt and F8, we run the SIDD macro, we ask the macro to create a new simulation for the UK, we give that simulation a name. I'll give it the name 2016p _ base. You could give it whatever name you like. we change the start year to 2016, we change the end year to 2050, and we ask it to run analysis based on the 2016 tax and benefit structure. We hit enter, enter and run, and launch the model. And that's it. So we haven't actually done anything substantive at this point. All we've managed to do so far is project the evolving population cross-section forward from 2011 through to 2016. And this simulation now projects it for the population forward from 2016 through to 2050. Again, the simulation will take quite some time, not quite as long as the preceding simulation. I think it's something like 2.5 hours or so on this workstation. Nevertheless, it's too long to wait for in this this tutorial, so we'll come back again once the simulation is complete. Okay, so once again, the simulation ran all the way through. It gave me a message saying that the requested simulations had all been complete. And I close the window and we're ready to use the macro in order to establish a definitive base specification. So we double click on this job file again, Alt F8, run the macro, we copy and paste the simulation name that we've just run, and we convert the run to a new base. Exactly the same thing we did with the 2011 base, except in this case we're using the 2016 base. So basically this macro should run all the way through and give us a message saying that that everything is complete. And then we'll be ready to set up. There we go. Everything's done, all set. So now we're ready to begin projecting the policy counterfactuals that are the principal subject of interest here. So to do that, we double click on the job file once again. Double click on the job file once again, open it up, Alt F8, run the job file, a new simulation. We'll call this tax rate plus 10 underscore 0, just as a beginning. We'll leave everything else fixed here. So what we're trying to do here is run the case in which the tax rate is increased by 10 percentage points for all taxable income. We'll hit enter. We will create the statistics for equivalized income deciles. The birth cohort I think we'll take as 1981 to 1991. Here. And we will generate comparative statistics with the population base. So basically these statistics here will be useful in the final section of this tutorial. Basically they're just to allow us to work out the incentive effects that are driving the projected results. We hit enter. There's nothing that needs to be altered in these cells. All we need to do now is alter the tax rates that are the principal focus of interest here, and we're increasing those by 10 percentage points. So we put 30 here, 50 here, and 55 for all others. And that's it. And then we hit enter, enter and run. Now, sometimes it's useful to hit exit here just to see what parameters have been altered by the macro in order to set this simulation up. So the input sheet includes the model parameters that the model is being asked to run. In this case, the input A are the base parameters, and the check allows us to find differences between the two. So you can see that there are 10 differences here. So if we go across the top, 6 of those differences are in column AI, and 3 of them are here, rows 12, 13, and 14, and then the other 3 are down here at rows 106, 107, and 108. If we look at the input sheet, go across to AI, we can see that if we go down to 12, 13, 14, recalling that it was 12, 13, and 14 where the differences were, you can see that it's gone 0.3 from 0.2. Basically, if we have a look on this sheet, you can see that here it's 0.3, this cell. Here it's 0.2. Just below that is 0.5. It was 0.4. Just below that it's 0.55. It was 0.45. If we go down, we can see that row 106 was 0.45, it's now 0.55, and indeed all of these are the same. So so all of those parameters have been adjusted as requested, which is a good thing. So that's 6 of the differences, and that leaves 4 differences still to find. And the other changes we made were in the analysis sheet. This is row column BQ. You can see that they're all down here, basically rows 35 to 36, and all of those are simply turning on this decile level analysis. So everything seems to be working and in order. So we're all set to go. We save the file. We close it as soon as it's done, although you don't need to close it, and double click on the SIDD exe file. It says that it's running the file. Once again, this simulation will run all the way through, and it should take 2.5 odd hours in order to do that, and we can come back and as soon as the simulation is complete. Okay, so the simulation again ran all the way through, no problems, closed the window down, and we're ready to get on. So basically that simulation ran the case in which both savings and labour supply respond optimally to the policy environment. How do we get the model to do the same analysis, but for the 2 alternative behavioral sets of behavioral assumptions that are the focus of this study? Well, if we open up the job file here and go to the input sheet. Okay, so the second, the first of the 3 behavioral alternatives that were referred to on the PowerPoint presentation involved assuming that the behavior, consumption and savings behavior, remained functionally invariant to the policy counterfactual. To do that is really quite straightforward. We might put 1 here to distinguish it from the preceding simulation. And then, so that will give it a new name, otherwise we would be writing over the results from the preceding simulation. And then what we want to do is use the grids from another simulation, that is our base specification, and here we want to put in the name of our simulation base to load those grids in from. So now what the model will do is, rather than solving the lifetime decision problem for the model based upon the policy counterfactual, it will simply load in the grids from the base policy environment. If we save that and run it, that will give us our second behavioral alternative that is of interest here. Now, the final case in which labour supply and is assumed to respond to the incentives of the respective policy counterfactual, but savings and indeed pension decisions are not, is enabled by doing exactly the same thing, but altering the job file name, obviously, to something new. Here I might call it _2. We want to continue to load in the grids, but now what we want to do is get the model to switch on this new facility that we've programmed up in the model. We save that, and then we can run the model in order to run the third behavioral alternative. And really that's it. That's all that this analysis really requires in order to project the data that are necessary in order to work out the effects that these policy counterfactuals have through time, and how sensitive they are to the respective behavioral alternatives. We'll come back to look at those data in the next and final part of this tutorial series.